Welcome to the program, Significant Changes in the 2024 National Design Specification for Wood Construction. As many of you know, the National Design Specification for Wood Construction, or NDS, is referenced in the U.S. building codes for design of wood members and their connections. My name is Philip Line. I'm a structural engineer with the American Wood Council, and it's my pleasure to be presenting on the 2024 NDS today. Here is a disclaimer required by our lawyers. Okay, course description. This program will be on changes appearing in the 2024 NDS, approved as an American national standard in October 2023, and replacing the 2018 NDS as the latest available edition. I'll be covering changes that are editorial in nature, that is, those changes that clarify requirements without changing the required member or connection size. I'll also be covering changes that revise or expand the technical requirements and will have an effect on member or connection size relative to the prior edition. The areas of significant technical change in this edition are for shear design, notching, connections, and fire design. And I think you'll see by far the most prevalent changes are for clarification. That is, to clarify the intent or language in the NDS without changing member or connection size. In this program, I'll be talking about scope of the 2024 NDS, how it is referenced in the 2024 International Building Code and the 2024 International Residential Code, changes occurring in the 2024 NDS and NDS supplement, and resources for additional information, just primarily the NDS commentary. Starting off with a little bit of history, the 24 edition of the NDS is the 18th edition of the standard. The NDS was first issued in 1944 as the National Design Specification for Stress Grade Lumber and its Fastenings. And in 1977, the title of the specification was changed to its present form. This slide shows the scope of the 2024 NDS, which is the structural design of wood products and their connections. This basic scope has remained unchanged since the 1944 edition. Beginning in 1944, the standard included visually graded lumber and glued laminated timber. In 1968, machine stress rated lumber was added. Now it's grouped under mechanically graded lumber. 1971, round timber piles was added. In 2001, round timber poles, prefabricated wood I-joist, structural composite lumber, and wood structural panel chapters were added. And in 2015, a chapter on cross-laminated timber was added. Other milestone changes that occurred but are not picked up in this scope statement will follow. I thought I'd include these, knowing that many designers use the NDS for evaluation of existing structures, and knowing where some of these major changes occurred may help in the assessment of the building's vulnerabilities based on the design requirements at that time. So beginning with the 1968 through 1977 editions of the NDS, in particular 1968, 1971, and 1977, the standard saw reduced tension design values for either glued laminated timber or sawn lumber, based on a better understanding of the effect of strength reducing characteristics such as knots on member bending and tension properties. In 1971 NDS, this was the first edition where lumber design values were based on full implementation of the National Grade Rule of 1970. This implemented standard grade names and descriptions for dimension lumber of all species that carry forward primarily intact still today. In the 1991 NDS, we saw the introduction of the yield limit equations for calculation of connection lateral design values. 1991 NDS also implemented the equation format of the NDS, where adjustments to design properties are explicitly named and then applied to the reference design value. Also, at that time, results of the major in-grade lumber testing program led to changes in dimension lumber design values, values generally being higher except for bending values for lower grades and larger widths. In the 2001 NDS, the fire design of wood members chapter was added for the first time, and also Appendix E chapter for evaluation of wood strength limit states and connected wood members was added for the first time. In the 2005 NDS, LRFD was added, making the standard a dual format allowable stress design and load and resistance factor design standard. A side note is that LRFD was first introduced for wood design in the Joint American Forest and Paper Association American Society of Civil Engineers Standard, AFMPA ASCE 16-95, and that was first published in 95. And then finally, in 2012 NDS, the supplement errata to that edition revised design values for southern pine. Notably for bending, there was about a 10% reduction in bending design values. Other changes to design values in tension, compression parallel to grain, and MOE also occurred. The 2024 NDS is referenced in the 2024 International Building Code and the 2024 International Residential Code. In the 2024 IBC, primary references are in 2306.1 for allowable stress design of wood construction, 2307.1 for load and resistance factor design of wood construction, and 722.1 for calculated fire resistance of exposed wood members and decking. In the 2024 IRC, the primary reference is in R301.1.3 for engineered design of wood construction exceeding the limits of the IRC. These code sections describe the general reference to the NDS, but more simply for folks that aren't familiar with the NDS is used to size all structural wood elements, including wood rafters, floor joists, headers, beams, columns, and their connections in the IRC and the IBC. This is the first of several slides taken from the redline version of the 24 NDS. The redline version is something the AWC Standards Committee uses when balloting the near final version of the NDS. New material is shown in red underline, and deletions from the 2018 NDS are shown in red strikeout. I'll be stepping through the redline version of the NDS. It has 16 chapters, 14 appendices, and a reference chapter section. And by the end, my hope is that those of you using the 2018 NDS will have a very good feel for changes coming with the 24 NDS. And for those of you already using the 24 NDS, hopefully this will help you more quickly determine if there was a change from something you were doing previously. So this is the one and only slide dealing with changes to Chapter 1. You'll see a change in 1.4.2.1. The term approved, meaning acceptable to the authority having jurisdiction, was added. And it primarily comes into play when referencing manufacturer's approved instructions or manufacturer's approved evaluation reports. It also comes into play for use of approved alternate methods, alternate to those that are prescribed in the NDS. Another change showing up in Chapter 1 is deletion of the diaphragm factor in notation. I'll cover that more in Chapter 12. And also addition of the term A effective bearing. And that happens in Chapter 16, so I'll cover that when we get to Chapter 16. For Chapter 2, Design Values for Structural Members, all the changes are shown on this slide. We can see in footnote 2 of Table 2.3.2, the words treated with are added. And this is done to clarify that load duration factors greater than 1.6 do not apply whether fire retardant chemicals are applied to wood through a pressure process or an alternative process that does not involve pressure. A similar clarification appears in section 234, except to achieve the same intent, the word pressure is deleted from pressure treated. One other change occurring in 234 is replacement of lumber and structural glue laminated timber with the broader term wood products, because a range of wood products can be treated with fire retardant chemicals, not just lumber and structural glue laminated timber. So moving on to Chapter 3, this is the first of several slides dealing with design provisions and equations for design of wood members as beams, columns, tension members, and is not a product-specific chapter. As you'll see, most of the changes in Chapter 3 can be categorized as clarifications without leading to a change in member size. Section 313.4.1.2 is a relocation of existing criteria to follow principles of engineering mechanics. 3415, 3416, and 3417 are pointers to other sections of the standard to help users locate relevant requirements. In section 3.4.2, shear design equations for bending members without notches or taper cuts, we have revised format of shear design equations that now solve for adjusted design shear, VR, instead of actual or induced shear stress, little FV. This can be seen in revised equations 341 and 342. One of the reasons for the change to a capacity value formulation for unnotched members versus a stress value FV formulation was to line up with notch shear design equations also appearing in Chapter 3, and we'll see that on the next slide. Equation 343 for adjusted design shear VR for a circular cross-section member, such as a pole or pile, is new in the body of the standard, but this equation showed up in the 2018 NDS commentary as well. So in section 343, shear design equations for bending members with notches and taper cuts, you see a lot of changes, but most are clarifications and do not affect required member size relative to the 2018 edition. Notice that the equations for adjusted design shear remain unchanged in 343 and 344. Just referring back to the prior slide, also notice this VR formulation for design shear of a notched member. I do want to draw your attention to one area where a change could be construed as significant change, and it depends very much on how the prior version was being interpreted. It's item D right here. You can see by my pointer, and I'm going to read it. A gradual change in cross-section compared with a square notch decreases the actual shear stress parallel to grain nearly to that computed for an unnotched bending member with the same depth dn. So this is saying if you had a taper cut potentially running into a notch, that dn, the depth remaining, could be used in the calculations versus the stress concentration term that we have right here. And it could lead to significantly smaller member size to resist the same shear. And, an illustration of a square corner notch is shown here on the lower figure. And this taper cut running into that notch is shown on the upper figure here. And this language was being interpreted by some to avoid use of the stress concentration here and rely on calculations just with dN, depth remaining. So in the end, after realizing how this was being interpreted, the committee didn't feel that relaxation or avoidance of stress concentration was warranted across all cases. There's a caveat I'll mention in a moment. And so this item D and yellow highlight I showed is stricken. And it's replaced with language in item C. And I'll read it here, do some highlight and read it. Where taper cut is used to reduce stress concentrations at a notch on the tension face, determination of the adjusted design shear capacity shall be in accordance with 1.1.1.5. And so the end result, and if you go to 115, it mentions testing and analysis and alternate means subject to approval by a code official, and that's what is intended by that pointer. It was mentioned during committee deliberations on these provisions that there had been some testing and potentially ongoing testing that could justify potential use of depth remaining dN only without stress concentration for certain applications, and that's why this provision is written the way it is. One other change that is happening is adding an equation for rectangular members where notch or taper cut is permitted on the compression face away from the end, the ability to use d sub n in the calculated design shear. So here is the new equation added. It applies to a condition where there's a notch on the compression face, a permitted notch on the compression face away from the end. And while this equation is new, it does lead to a solution that is the similar endpoint or the same endpoint that I feel many people would have arrived at using equation 345 and the criteria where E is greater than D sub n. If you go through the algebra and set E equal to D sub n, you do end up with this equation here for the design shear on the compression notch. Another change that's happening, and that's one I like when we add figures to the NDS, is a figure 3D update. And in this update, this single figure that we had with a compression notch and taper is being replaced with three separate figures showing compression face notch here, a taper cut, and an end notch tension face. So one figure is really being replaced by these two, and then there's an additional tension face and notch figure shown to depict the variables. So more chapter 3 here. Again, these are simple clarifications without changing the required member size. And item C here, it was deemed to be more clear to indicate that notch shear equations are applicable where a wood member is notched to bear on a bearing plate than where a concealed hanger is used. The key part is the notching of the wood member triggers use of the notch shear equations, and we have the same end result. There's no change in member size here between the 2018 NDS and the 24 NDS. Still in Chapter 3, but for compression members. And the changes here, again, are clarifications. And what's being clarified here is that built-up columns can be designed in different ways. They can be designed using built-up column provisions of Chapter 15, and those provisions assume a partial composite action and allows one to design these built-up members as a solid column, but take a percentage of the strength, solid column strength. And then another way that built-up columns can be designed is to design each individual lamination of the column, of the built-up column, as a single column. And that method is commonly done, say, in stud packs and other built-up members. And a reason for that is the built-up column provisions have limitations on fasteners that need to be used to connect individual laminations, their spacing, their size, etc. And they can be impractical in many cases. And here what we're showing is a figure from the built-up column provisions showing, fastener spacing, there's fastener size requirements, penetration requirements through the laminations, and edge distance, etc. All right, still in Chapter 3, but this is the final change in Chapter 3 and purely editorial. E-min notation is added to support the use of the column stability factor equation. And it's basically clarifying that when you're running the calculation, use the appropriate E value, E about the x-axis or y-axis, depending on the axis of buckling. Moving into Chapter 4, this is the adjustment factor table. And an adjustment was just simply missing from this table. It had existed in the NDS supplement. It was the flat use factor adjustment for beams and stringers on E and E-min. Here's what the adjustment looks like. And you can see there's one case for E and E-min where the value is 0.9, i.e. it's less than 1. And so it's important to show that in this table so it doesn't get lost and we can get a proper calculation. Also in Chapter 4 are revisions to address notching of sawn lumber. And these edits coordinate with the ones we were looking at in Chapter 3. I think the most important part is to recognize that there's no change in size and location of permitted notches. So notches at ends are limited in depth to 1/4 the beam depth right here. And that's tension side or compression side. Additionally, there's language to clarify that this applies to taper cuts. And then in section 4432, you'll see that interior notches located in the outer third of the span are limited to 1/6 the depth of the member, right here. And interior notches on the tension side of 3.5 inch or greater thickness member are not permitted. Finally, on this slide, 4B is updated, depicting the compression, notch, and taper cut. Moving on to Chapter 5, Structural Glue Laminated Timber. Much like Chapter 3 and Chapter 4, the additions you see here are primarily to clarify existing requirements and provide pointers. Figure 5F is new. It depicts all of the former compression side notch and taper cut limits that were in the prior edition of the NDS with one exception. There is a new limit that was not in the NDS, and it is right here. And so this one is on the compression side, and notches shall not extend into the middle third of the span, nor more than 3dn. The 3dn limit is from AITC and APA literature on glue lam notching. And the committee noticed that this limit was missing in the NDS upon balloting changes to this chapter. Here is the lesser of 3dn or span over 3 limit in the figure. For users that were using APA, AITC guidance, and NDS altogether, this reflects no change. However, this is new in terms of NDS provisions. Other things remained unchanged. On the tension side, the end notch is limited to 1/10 the depth of the member, or 3 inches. And then compression side end notches or taper cuts are limited to 2/5 the depth of the member. No change there. Okay, Chapter 6, round timber poles and piles, no changes. Chapter 7, prefabricated wood I-joist. The major change being made here is the language manufacturer's approved recommendations throughout the section. So when you're seeking design values, that comes from approved recommendations or approved evaluation reports. In Chapter 8, dealing with structural composite lumber, again, we're picking up manufacturer's approved recommendations or approved evaluation report. And then for notching, like prior chapters, these changes are purely to be more clear on what the requirements are without technical change. The exception might be explicit clarification of how to deal with taper cuts, but I believe those judgments were commonly being made anyway. Just taper cuts. And so here's the 1/10 the depth limit that lines up with what's in place for glulam, and that's on the tension side. And then on the compression side, here's the 2/5 the depth of the member, which lines up with the 2/5 we saw for glulam. We have new figures added, figure 8A, end notch on the tension face. Figure 8B is end notch compression face and taper cut. One thing I want to circle back to, I didn't draw attention to this for sawn lumber or glulam, but in each of the product chapters, this is the SCL chapter, for notches, the language has this similar construction. Keep in mind this is specific to structural composite lumber, but like I said, similar language applies to sawn lumber and glulam. And I'll read it here. It says structural composite lumber bending members shall not be notched or taper cut except as permitted in 8411 and 8412. And you see both of those sections are on this slide in their entirety. And those sections describe the full extent of permitted notches in the NDS. And then the follow-on is the effects of notches or taper cuts on strength shall be determined in accordance with 312 and 343. So those are those shear equations we looked at earlier. And the key point is that those equations are can be viewed as only valid within the range of notch limits specified in each of the product chapters. Here we see the notch limits for SCL. As I mentioned, we had notch limits for glulam and notch limits for sawn lumber. For notching outside of those ranges, the equations simply don't apply, and the NDS does not provide a direct method for calculating strength. Moving into Chapter 9, wood structural panels, no changes. For Chapter 10, cross-laminated timber, we see this language, manufacturer's approved recommendations or approved evaluation report. No other changes. In Chapter 11, 11.3.2, there are a lot of edits, but it leads us to the same technical endpoint. Load duration factors do not apply when metal parts or concrete or masonry parts control the design. That's the same intended outcome of former NDS language, but stated more clearly. And then in 11.3.5, fire retardant treatment, we see the same revisions that were implemented in Chapter 2 So no technical change here. In table 11.3.1, the diaphragm factor is being deleted, and I'll be covering this a little bit more in chapter 12. Now we're in chapter 12, dowel type fasteners, and there are more extensive revisions happening in this chapter. One that is fairly straightforward using the same principles we've used for other fasteners is the addition of metal hardware nails right here. These nails, as the name implies, are typically used to attach metal hardware, devices like hangers and straps. We see here bearing strength from approved recommendations or approved evaluation report. This addition down here for double shear connections is a relocation of information formerly showing up for asymmetric three-member connections in the NDS. It's basically saying if you have unequal side members, use the smaller side member in the double shear equations. No technical change here for that update. Here's where we get into some significant technical change. And I want to highlight something that was original text or existing text in 2018 NDS for multi-shear connections, basically 4 more members or 3 or more shear planes. And the basic provision is right here. The reference lateral design value Z for the connection shall be the lowest reference lateral design value for any single shear plane multiplied by the number of shear planes. So applying this provision to the connection above, right here, we have 1, 2, 3, 4 shear planes. The total Z value for the overall connection would be the minimum Z value for each of the individual shear planes that make up this connection here, 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 and here, times the number of shear planes. And as large wood member connections with knife plates have become more prevalent with heavy timber and the increased use of heavy timber, we had reason to revisit these provisions, and we did identify cases where this existing criteria might give values that were unconservative to a more detailed analysis. And so what we did is we came up with a design approach still based on applying the yield equations to capture a proper Z value when there's multiple shear planes. And it basically splits the analysis into 2 categories. For a connection with an even number of members, you'd follow the approach in 12.381. And for a connection with an odd number of members, you'd follow 12.382. And I'm just going to describe the steps here to convey that it's a direct calculation approach rather than solving a specific problem. So when there's an even number of members, you evaluate the overall connection as a series of single shear planes to find the minimum Z value. And here we do single shear connections. You determine the minimum Z, and the overall Z is taken as Z minimum times N over 2. Okay? And when there's an odd number of members, you'll analyze the multi-shear plane connection as a set of double shear connections. Okay? You find the minimum Z value from breaking the overall connection into a series of double shear connections. And then the total Z is taken as the minimum times the quantity N minus 1 divided by 2. and that's right here. Okay, and that will get you the final Z value for the overall connection. It's much more direct than a detailed analysis, which still could be done. All right, moving on to the diaphragm factor, and here we see it's being deleted. And the reason for the deletion is the factor is no longer considered necessary. The factor has been included in design values in the special design provisions for wind and seismic. And because the factor itself was based on tests of nailed structural panel diaphragms, the potential to apply this to other diaphragm types was viewed as limited, and it just didn't seem warranted to continue with the factor. So it has been deleted. Here's a table adding the metal hardware nails. And again, following the same principles used for other nail design value tables. Something unique here is that the metal hardware nail tables incorporate values for low to medium carbon steel and medium carbon steel. And the footnotes are here. I know it's hard to read. These footnotes reflect different bending yield strength assumptions for the nails, depending on whether it's low to medium carbon steel or medium carbon steel hardened. Moving on to Chapter 13, split ring and shear plate connectors, no changes. Chapter 14, timber rivets, no changes. Chapter 15, special loading conditions, only an editorial clarification for resisting buckling added to the space column provisions, right here. Okay, in Chapter 16, we have significant changes. Overall, Chapter 16, we have changes that fall under reorganization, but most are to align with the requirements in the 2024 Fire Design Specification for wood construction. Before I get into some of those, I wanted to describe our committee concerns as we were expanding Chapter 16 of the NDS. And the basic concern was we are expanding the kind of calculations that were needed, conditions that needed to be considered, etc. And there was concern that these calculations would always be required because they exist in the NDS, and that the designer would be responsible for providing such calculations in all cases. And what we worked out is that Chapter 16 is viewed as a standard tool to help demonstrate compliance of wood to meet code requirements for fire resistance, for calculated fire resistance to be more specific. And so if it's required, if there's a requirement for a calculated fire resistance, or if there's a pathway where calculated fire resistance can be used to demonstrate what is acceptable, then Chapter 16 can be used and viewed as a tool. It's not the other way around. The existence of the approach doesn't require it to be used in all cases. And that became clear in our discussions, and it's also reflected in the updated commentary to the NDS. So the big change here in 16.1 is adding the reference to the fire design specification for wood construction. As part of the Chapter 16 reorganization, 16.2 is revised to address charring of wood, and 16.3 is revised to address fire resistance. 16.223 and 16.224 point to FDS for less common configurations and analysis of char and CLT. Pointers were considered preferable for NDS over duplication of FDS requirements in the NDS. You can see that in 16.223 addresses CLT with laminations of unequal thickness, and 16.2.2.4 addresses detailed analysis of CLT char penetration between laminations. Here, existing information in Chapter 16 of the 2018 NDS is largely regrouped under 16.3 structural fire resistance of exposed wood members. Most of the new information is brought forward from the 2024 FDS to bring consistency with requirements of the FDS. One new item is here in 16315. And it was something we first saw in this program in section 1.6 notation. And it's the addition of a effective bearing. It's a new term. And what it's doing is recognizing that the char depth for bearing is 1.5 HR. And this accounts for the increased loss of strength and stiffness in bearing perpendicular to grain applications. The NDS has good commentary on this as well as the FDS. In these sections, changes are mostly improved language, and for lumber decking, revisions bring alignment with more detailed language of the 2024 FDS. Again, in Chapter 16, this is the final slide. We have new adjustment factors for shear strength and bearing strength, and a footnote, caution against further application by load duration, temperature, and moisture factors. These line up with the fire design specification. 16.4 on structural fire resistance, protected wood members, lines up with requirements of the fire design specification. In fact, there's a pointer there to the FDS. And then in section 16.5 wood connections, it incorporates a pointer to the FDS and cleans up language. Moving on to appendices. Appendix A, construction and design practices, no change. Appendix B, load duration, no change. Appendix C, temperature effects, no change. Appendix D, lateral stability of beams, only editorial change with E-min notation added. Appendix E did receive changes, and they are going to appear extensive, but they are primarily for two reasons. One is expanding Appendix E to address single fastener wood strength limit states. And then the second is a basic cleanup of the examples to make them easier to follow. And here's the single fastener inclusion in Appendix E. So here are some changes in Appendix E addressing addition of single fasteners. Note here, and then a full example for single fastener is all in here. Here is a new example addressing a single bolt connection. Here's a clarification for multiple bolt connection with a staggered row of bolts. Language is updated, but there's no change in the final answer. Here, the single row bolt example is updated. No change in final answer. Single row of split rings is updated. No change in final answer. Appendix F, designed for creep and critical deflection, no change. Appendix G, effective column length, no change. Appendix H, lateral stability of columns, editorial change only with E-min, notation added. And then Appendix I, metal hardware nails added in the appropriate sections for fastener bending yield strength. Appendix J, solution of Hankinson formula, no change. Appendix K, typical dimensions for split ring and shear plate connectors, no change. Appendix L, typical dimensions for dowel type fasteners and washers. Metal hardware nails are added. If you scrutinize the table down here, you'll see the diameters and lengths, generally shorter lengths to account for the thinner side member of metal hardware. The nail is available in both smooth and ring shank, and the head diameter in all cases is 0.281 inches. And that happens to be a common size for power tool nails. Appendix M, manufacturing tolerances for rivets and steel side plates for timber rivet connections, no changes. Appendix N, load and resistance factor design, no changes. And then for references, reference to the Fire Design Specification 2024 edition is added. So the NDS supplement includes a few changes this cycle. This slide is just to show the extent of design value tables in the 2024 NDS supplement. Only a few have changed, and I'll highlight those. One of the design value tables changing is for glulam. The primary change is the replacement of EX apparent and EY apparent in the glulam tables with EX and EY. I know this is hard to read. I apologize for that. So now the tables have three sets of E values. EX true, which is a shear-free E. EX, which is an apparent E. It includes the effects of shear deformation. And then EX min. And there's the similar notation for EY. EY true, EY, and EY min. And then those values are described in greater detail and expanded footnotes. Importantly, I think this will be helpful to the users, is the EX min and EY min are stated as to be used in beam stability and column stability calculations. These similar types of changes for E are in glulam tables for glulam, primarily stressed in tension as well. And here's table 5B for glulam. This table is geared towards applications where the member is stressed primarily in axial tension or compression. And we'll see similar changes going on with E here, as well as clarification in the footnotes. Another change is addition of table 4G, reference design values for multi-species and country grade marked visually graded dimension lumber. The label is fairly complex because many species are usually involved in each of the groupings. I'm showing one page of this table, but this table spans multiple pages in the NDS supplement. And there was an addendum to the 2018 NDS supplement that had the same type of information, but this is the first time this table has formally appeared in the NDS supplement. So moving on to NDS commentary, it's a great resource for additional information, and I'm going to show some examples here now. Here's a new commentary figure to show how individual members of a multi-ply stud pack can be designed as individual columns with wall sheathing nailing to those individual columns to function as bracing. So this is figure C36. And we're looking at 3 studs in, say, a stud pack with sheathing nailing to each individual column to function as bracing for the column in the weak axis. Here's an example of a commentary figure of notches not meeting the NDS requirements. I know many of you might be thinking you're aware of cantilever or balcony applications where these have been used and performed well, but the X mark is shown here because they're not explicitly permitted in the NDS. And one of the reasons is for that top loading condition, which balconies are subject to, you can get potentially high shear moment in the notch location. And that's a different situation than the typical NDS notch, where there may be high shear, but moment is near zero at the end of a simple span member. The commentary also depicts a figure of a taper cut on the tension face of a glulam beam. And you can see the notch limit applies there. And finally, to help support the multi-shear plane connection expansion in the NDS, there's new figures depicting limit states and commentary to help explain the new requirements. And with that, we've reached the conclusion of this program, and I wanted to thank you for your interest.